Good day, friends. Today we're going to be solving some of the questions we're given as a take home in our previous lesson on the law of conservation of matter. In our previous lesson, we did some very wonderful job on, on the law of conservation of matter. We did some arithmetic job on that. So we're given two major questions to get ourselves tested to see how much we got from that very lesson. And here was the very first question we were given: which of these chemical equations support the law of conservation of mass? Now we have two major equations here. The first is zinc reacting with HCl to give us zinc chloride plus hydrogen gas. And the second equation we have is methane, that's a methane gas, CH4, plus oxygen to give us carbon dioxide and water. So the question is, which of these equations, you know, obeys or supports the law of conservation of matter or mass? And don't forget what the law says. The law states that in a chemical reaction, there's no way matter can be created or destroyed. It's not possible. So probably to summarize that, it was explained that by the time we get the total relative molecular mass of the reactant, it's gonna be the same thing as the total relative molecular mass of the product. So it means matter is not being created and matter is not being destroyed, regardless of the kind of product we get. So let's see quickly which of these equations obeys or supports the law of conservation of mass. So as you can see, the zinc, one atom of zinc, one atom of hydrogen here, one atom of chlorine. Here, one atom of zinc, two atoms of chlorine, and two atoms of hydrogen. Now, as you can see, for the fact that zinc here is one, that's fine, it's balanced. Hydrogen here is one, hydrogen here is two, then it's not balanced. Chlorine here is one, chlorine here is two, then it's not balanced. It's not balanced, as you can see. For the fact that we have this imbalance in the reactant and the product side, it means this does not support the law of conservation of mass. Now, how do we get to know that? How we get to know that is that by the time we get the relative molecular mass of the whole reactant, and we also get the relative molecular mass of the whole product, we're going to have a kind of disparity. They won't be the same thing. We're going to have the higher result on the product that's relative molecular mass than what we have here on the reactant side. So there's no way this very equation obeys the law of conservation of mass. Why? Because the equation is not balanced. As simple as that. So let's look at the second equation. CH4 plus 2O2, CO2 being given, and two molecules of water. So carbon here is 1, carbon here is 1. Hydrogen is 4 atoms. Hydrogen here is 4 atoms. 2 times 2 is 4. Now oxygen here is 4 atoms. Oxygen here is 2 atoms of oxygen on this side, on the carbon dioxide side, and also 2 here. So altogether, we have a balanced chemical equation here. So this obeys the law of conservation of mass. Now we can do the calculation quickly to see if you are right. Don't forget carbon is 12, hydrogen is 1 atomic mass unit, oxygen is 16. So let's quickly do the math. So carbon is 1 atom, so that's 1 times 12. Then plus hydrogen is 4 atoms here, 4 times 1. That's after that. And then oxygen here is, we have 4 atoms altogether, that's 4 times 16. That will give us carbon here, 1 atom, 1 times 12. Then oxygen is 2 atoms, 2 times 16. Then hydrogen is 4 atoms altogether, 4 times 1. Then plus oxygen is 2 atoms altogether, 2 times 16. So let's see if you're going to have the same relative, molecular mass result, on the reactant side compared to what we're going to get on the product side. If you get the same thing, it means the law of conservation of matter has been obeyed. So quickly, let's carry on. 1 times 12 is 12. 4 times 1 is 4. Then plus 4 times this is 64. Then equals to 1 times 2, 12 is 12. 2 times this is 32. Then plus 4 times 1 is 4. 2 times 16 is 32. You have that. So 12 plus this is 16 plus 64. That's on the reactant side. Then the product side, 12 plus this is 44 plus 36. So it's high time we added this up. So 16 plus 64 will give us 80 gram. 44 plus 36 will give us 80 gram. So the law of conservation of mass or matter is being obeyed right here, as you can see in the second equation. If you try the same thing for the very first equation, you're going to get different results on the reactant and the product side. And that's the reason this is the only equation that really, obeys the law of conservation of mass. Now, why? This very number one equation is not balanced, as you can see. So that's that for the very first question we're given as a take home in our previous lesson. So stay tuned for the very second question.